so let's see here. What am I given? 1.05. Find speed. Okay, so we're given, well, we're given that 25 degrees. So let's say this. The tangent of 25 is what? It would be the centripetal acceleration divided by the tangential, right? If you look at the triangle, see that? And so, but also the centripetal acceleration is equal to v squared over r. See, this is true. The centripetal acceleration being v squared over r is true even when the speed is not constant. It's like it's always v squared over r. That describes the center-seeking part of it. We worked this out in Calculus 3. There you go. You're like, great. The point is, a sub c is always v squared over r, all right, which is a magical formula that I give you guys. And so if you look at what you got, you have a squared is equal to ac squared. What's at? Well, excuse me. My point is, if you put these things all together, you can solve it. You've got one equation, one unknown. Let's see if I can find a spot to do that. All right, so getting to it, we have AT is equal to AC, well, times the cotangent of 25 degrees, if you like that. No one likes that. That's not, oh, hideous. It's not in your calculator, is it? You had a cotangent button on your calculator? Probably not. But you do have a tangent button, right? So we can calculate that. And so we've got a squared is equal to AC squared plus AC squared divided by tangent squared 25. Well, not tangent squared, just tangent 25. I'm an idiot. And if you look at that, we've got AC squared times 1 plus 1 over tangent of 25, yeah? But what else do we, so what do we know? So we've got that AC squared is, what is it? It's a squared divided by 1 plus 1 over the tangent of 25. Let's figure out what that number is. We could figure that out without too much work, right? We're given A. Yeah? So what is this AC squared actually equal to? All right, 1.05 squared. So I'm glad you asked about this because I don't think I've said quite enough about circular motion, and I think this is a good example to complement what I've already said. Yeah. We don't go that deep into circular motion at the moment. Pretty much your primary responsibility as a physics student at the moment is simply to learn the v squared over r formula and where it applies. So specifically, I'm talking about, orbital motion for the most part. I can't read. 25. What did you guys get? What did you guys get for this fraction? Anybody? I got 0.3506. Am I alone in my calculation, or is that what you guys got? Okay, so at least we're both wrong together, or right together. Quiet down. Sonny. Uh-oh. Uh-oh. I forgot I armed him earlier. Ah! You're teaching them a bad lesson. Stop that. All right. All right, so then that makes AC equal to what? AC is the square root of that, yeah? Which is 0.5921. And what is that equal to? Remember what I said, your primary responsibility as a student is knowing this formula and when to use it. That's pretty much all we're doing for circular motion at the moment. V squared, we'll do more later. V squared over R. Do we know R? Oh yeah, we know R. We're given R, right? So we can find V. V is equal to the square root of 0.5921 times 1.95, which is whatever it is. I don't know what it is. I got 1.075. What did you guys get? 1.075 meters per second? And is that it's just number 27, is that the answer? Or is the book wrong? 0.930. Well, that is disturbulating. Is that that's the speed? Huh. Oh, I should have squared. I know what it was. I know what it is, guys. I should have. I said I had a squared tangent and then I backed off of it. That was wrong. This was squared, right? Because it's AT squared. That's supposed to be tangent squared. That explains the. That's the miscalculation. We were supposed to have the squared tangent there. That'll percolate through. That explains why we're close but not quite right. Yep. So guys, Thursday, I would like questions about the force, like the free body diagram stuff, all right? It's not, we have class Thursday, right?
Yeah.
Okay. And when is there? There's a spring break or something, right? Oh, fall break, yeah. Spring break, listen to me. Thanks, guys. You can stop recording. Did it stop? Did you hit the stop button?